When Tiger Commander SS Hauptsturmführer Michael Wittmann destroyed 12 tanks in 12 minutes at Villers-Bocage in June 1944, it vindicated Oberstleutnant Heigel's original 1941 concept. Overwhelming firepower and protection superseded mobility concerns. The Tiger's armor design originated directly from Reichsminister Tott's inspection of Panzer IIIs hit by Soviet 76mm shells in 1941. Chief designer Erwin Aders at Henschel implemented interlocked plates of face-hardened Krupp steel, 102mm at the front glacis and 82mm on turret faces, creating near-impenetrable protection against Allied 75mm shells at normal combat ranges. Its 8.8cm KWK gun fired 10.2 kilogram shells at 810 meters per second, penetrating 138 millimeters of armor at 500 meters, devastating when American Sherman tanks offered merely 76 millimeter protection. Field Marshal Rommel wrote after Sidi Bouzid, "A single Tiger equals 5 Shermans, but was it really that powerful?" The Tiger I's overlapping and interleaved wheel system, designed by Ferdinand Porsche and Henschel engineer Erwin Aders, represented one of the most problematic engineering choices in armored warfare history. This suspension utilized 24 road wheels per vehicle in 3 rows, creating a complex arrangement that provided exceptional weight distribution, critical for the Tiger's unprecedented 57-ton mass. While delivering superior cross-country performance on ideal terrain, this system became catastrophically vulnerable in mud, snow, and ice conditions, precisely where Eastern Front operations most frequently occurred. During frozen conditions at -20 degrees Celsius, ice accumulation between wheels caused track binding that immobilized entire battalions. When thaw arrived, the suspension became a mud trap. SS Hauptsturmführer Albert Kirscher of the 101st Heavy Tank Battalion documented that during Operation Citadel, 35% of Tiger breakdowns stemmed from this wheel configuration. The interleaved design required the removal of up to 9 road wheels to access a damaged inner wheel. Field repairs typically consumed 6 to 8 hours under combat conditions, compared to 30 minutes for Panther tank road wheel replacements. The Tiger's Maybach HL-230P45 engine, producing 700 horsepower, suffered from chronic reliability issues stemming from its rushed development cycle. Engine designer Wilhelm Maybach's company originally intended a longer testing program, but Hitler's demand for rapid deployment compressed this significantly. The consequences were predictable. The Tiger's operational readiness rarely exceeded 60% during its service life, according to maintenance records from Panzer Group West. Fuel delivery systems proved particularly troublesome, with high-pressure injection pumps failing at an average of 1,400 kilometers, approximately 1 month of operation. Fuel consumption represented another critical vulnerability. The Tiger consumed 530 liters per 100 kilometers on roads and nearly 900 liters cross-country. Each Tiger battalion required 45,000 liters daily, constituting an entire freight train of fuel supplies per week of sustained operations. General Heinz Guderian noted in his memoirs that during the Kursk offensive, fuel supply constraints often prevented Tigers from reaching optimal firing positions, forcing them into defensive postures within range of Soviet artillery. The 88mm KWK 36L/56 gun, adapted from the legendary Flyke 36 anti-aircraft gun by Krupp engineers, could penetrate 112 millimeters of armor at 1,400 meters. However, this formidable weapon carried significant drawbacks. The 2-part ammunition design, separate shell and propellant case, reduced the rate of fire to 6 to 8 rounds per minute, half that of contemporary Soviet 85mm designs. In cramped combat conditions, loader Franz Staudiger of the 2nd SS Panzer Division reported average rates declining to 4 rounds per minute during extended engagements. The Tiger's turret rotation mechanism, designed by Henschel engineers, utilized an electric motor rather than the hydraulic systems found in American designs. While innovative, this system drew significant power from the tank's electrical network. After the Battle of Kursk, Colonel Otto von Knobelsdorff reported that under combat conditions, the turret rotation speed dropped from the factory-specified 60 seconds for a 360-degree turn to over 90 seconds as batteries depleted. Soviet T-34 commanders quickly exploited this vulnerability by engaging Tigers from multiple angles, forcing constant turret traversal that drained power reserves. Perhaps most significantly, the Tiger's manufacturing complexity rendered it a strategic liability. Each Tiger required 300,000 man-hours to produce, 6 times more than a single T-34. Production director Dieter Stauber documented that Germany could produce either 1 Tiger or 6 Panzer IVs with equivalent resources and labor. When Field Marshal Walter Model requested additional Tiger battalions for the 1944 Eastern Front spring operations, Armaments Minister Albert Speer informed Hitler that Germany lacked sufficient specialized machine tools to meet demand. The Tiger's transmission, designed by Maybach and manufactured by Zahnradfabrik Friedrichshafen, required such precision that only skilled machinists could assemble certain components. General Heinz Guderian documented that a single misaligned gear could render the entire 13-ton transmission unit irreparable. The gearbox contained over 1,000 individual parts, compared to substantially fewer in contemporary Sherman transmissions. Combat performance revealed further operational limitations. The 45-ton design weight ballooned to 57 tons during production, exceeding the capacity of most European bridges. Each Tiger battalion required dedicated combat engineering support. During Operation Citadel, the 3rd Company of the 503rd Heavy Tank Battalion lost several Tigers that crashed through bridges rated for 40 tons, a limitation the tanks exceeded by nearly 40%. The Tiger's track system, 725 millimeters wide to distribute ground pressure, created transportation nightmares. For rail transport, crews needed to replace combat tracks with narrower 520 millimeter transport tracks, a 4-hour procedure that rendered Tigers vulnerable during deployment. During the Allied invasion of Sicily in 1943, as documented by SS Brigade Führer Fritz Witt, several Tigers from the 1st SS Panzer Division were destroyed by naval gunfire while undergoing track conversion at marshalling yards. Turning radius presented another critical limitation. The Tiger required approximately 19 meters for a neutral steer turn, whereas a T-34 needed only about 7 meters. During urban combat in Villers-Bocage, Ace Michael Wittmann lost tanks when they became trapped in narrow streets while attempting to maneuver. The after-action report by Major Heinz von Westernhagen specifically cited insufficient maneuverability in confined spaces as a significant factor in these losses. The Tiger's electrical system utilized copper wiring at a time when German copper supplies were critically depleted. Each Tiger contained hundreds of meters of copper wiring, enough to produce electrical systems for multiple Panzer IVs. When copper shortages intensified in late 1943, Henschel substituted aluminum wiring in non-critical circuits, leading to increased electrical fires. Tank Commander Otto Carius documented several such incidents in his unit within a single month. Air filtration systems proved woefully inadequate for Eastern Front conditions. The original Maybach-designed filters clogged after approximately 8 hours in dusty summer conditions. After-action reports from the 501st Heavy Tank Battalion during operations near Rostov documented engines inhaling fine dust causing accelerated cylinder wear. Filter redesigns improved duration significantly, but required field maintenance every 2 days, a significant operational burden that frequently rendered Tigers non-operational. Despite its fearsome reputation, the Tiger's combination of mechanical complexity, reliability issues, and strategic production costs rendered it more propaganda tool than effective weapon system. As Armaments Chief Albert Speer later wrote in his memoirs, the Tiger program consumed resources disproportionate to its battlefield impact. For every Tiger produced, Germany sacrificed the potential for multiple other armored vehicles that might have altered the strategic balance. Though intimidating to Allied forces, the Tiger ultimately represented an engineering overreach that Germany's wartime economy and logistical system could not sustain.